Hi everyone, welcome and thank you for joining another breakout session today. I'm actually surprised to see so many people who are interested in making old things better than building new things. Today's talk is about modernization and how to gradually migrate data from SQL to NoSQL. Whether you're an enterprise or a startup or a medium-sized company, you will find yourself eventually in a situation where you have systems, old systems, legacy systems that rely on SQL data, and they're getting slower. You have bad performance. They don't let you to innovate. They don't let you to build things quickly, to use new things that we announce at reInvent. So the thing is, how do we move there? How can we make sure that we can migrate from SQL to NoSQL data and actually adopt new challenges? And today in the talk, we will cover these topics. My name is Alex Schüren. I'm a solution architect at AWS. And today with me should be Darko Mezaros, but unfortunately, he has a live stream session on Twitch covering a new service that was announced in a keynote, and that's why he will not join us today. Today's agenda will be, first we will cover what is modernization journey, how does modernization journey look like for typical customers, and how does it fit into re-architecting systems, and especially considering the database size, because it's easy to think about how can we improve services and applications, but as soon as we get state and database, and we can't do it on an offline base, things start to get a little bit difficult. In the mechanisms chapter, we will cover the approaches that we have collected so far. I'm part of the team called Developer Acceleration Team, and we work with customers who are interested in modernizing the application. So the typical question they have is, how do I make the transition from the old system to a new system? How do I design things? What are the patterns I can use, tooling, best practices, and how can I adopt it very quickly? And over the time we worked with customers, we collected all this experience, all the things we tried out, because there are no blueprints for re-architecting systems yet. And thus, we try to come up with a mechanism that we can share this experience to you so your modernization journey might be more enjoyable and a little bit faster. Then, in the testing phase, in the testing chapter, we'll take a look how can we make sure that when we continuously migrate things, that we actually catch the errors, how we can handle failures, and at least know when things go wrong and remediate and roll back things. And by the end, we will have a demo where we live migrate, hopefully without issues, a small demo, just to demonstrate all these things that we will cover in the mechanisms. We will have a Q&A session at the end, so if you're interested, please collect your questions, and we can discuss them as well and have a little bit more on the discussion side. All right, modernization. So a lot of customers find themselves in a situation, okay, things are slow, we want to adapt new services, we want to maybe look into serverless, in event-driven architectures, how do we get there? But the issue that they have is they have hundreds or thousands of applications in database sitting somewhere either on-premises or in different cloud providers, and they want to move to AWS. We have invested a lot of time and a lot of effort into finding the best way to migrate the workload, and the more we do that, the more complicated it gets, because we realize that customer workloads is actually highly diverse. So we have by now programs for moving mainframes and SQL, Microsoft SQL specific things, and Oracle, and many different types of workloads. But the general way how to do that is typically to first make a discovery and assessment phase where we collect all the information that we need, technical information, server names, connections, who is talking to whom, why is it important, how important is it for business, and how can we actually move these things in the future. And then there is an important part where we have to distinguish what should we do with this application. And this is the famous R that we have, so you can repurpose things, you can retain, and my favorite is retire, actually deleting code and generating customer value I think it's the best feeling you can get. But the more we go to the refactoring side, the harder things actually get, but the more options we have. Because when we refactor application, we have to put a lot of effort. We have to understand what is happening inside, what are the dependencies, what will happen if we change things drastically. So you need a robust process there. You need to spend a lot of time and understand it. But the business value that you can generate for the customer is actually the most. So think about moving to serverless application and adopting purpose-built databases that will increase the performance and be more secure for the customer. But the way there is much, much harder than just relocating or making lift and shift. And based on the data we have collected, the typical way is just to rehost things or relocate maybe, or we put things in container and then we realize at some point, okay, now it works. We can scale actually containers, it's fine, but now we want to re-architect the system. And the typical case as well is with the database, because while we can split monolith into microservices, there are a lot of patterns, like a strangler pattern, for example, where you can provide an API and just route the traffic through a different system. For databases, it's not that straightforward. And thus, only 5 to 10% customers embrace the way of re-architecting, but we see this number is growing, and we have to do more in this area to help customers to re-architect their system. Just to recap on SQL and NoSQL, popular choice for moving SQL data is NoSQL, because a lot of stuff that was designed in the past was for the SQL database, and we put everything in one database and realized after that it's not the proper way to optimize it. So for the SQL part, we have relational data, and on the NoSQL side, on the DynamoDB, it's a key value storage. And the advantage for NoSQL is mostly the scaling part. So you can throw more data, you can throw more volume of data there, but the performance, the query performance will stay the same or slightly increase. But of course, there are some disadvantages in terms of queries, because we have to spend a lot of time to think about the structure, the schema for NoSQL database, and we have no flexibility compared to SQL. And when the customer comes to us and say, okay, we want to move now from SQL to NoSQL, we think it's a good idea, we see the value for the customer, it will be performant, we reduce costs, and there are some business benefit. And then there are a bunch of unknowns they face. So the first thing is, how do we design the schema? How do we do that? We will not cover this topic today because this is like an in-depth topic, and we have lots of great speakers as well as in reInvent and past sessions as well, like Alex Debris and other people that written books on that. But other things like, okay, when I move the data continuously and this fails, what should I do? How do I make rollbacks in this case? Because this is continuously changing process. Or how do I validate? Because once you move outside of the SQLs, you don't have the schema. So you have to take care of that you write the right values, that they have the type, and so on. And then you have end boss, which is, I think my personal end boss is stored procedures. When you spend a lot of time discussing what you can do better, and then suddenly customer drops in, oh, by the way, we have like hundreds of stored procedures, and we don't know what to do with them. I think this is a completely different topic to cover, and we will not do it today. But we will think about data consistency and how to do it continuously as well. Mechanisms. When we start working with customers on migrating things, the first thing is, how do I start? What should I do first? What is the first step I need to take? And it might sound weird, but we don't start with the schema. We start with the customer in mind. And this means that customer need to spend time to understand what would be the value if we design specific data for an application, for another system, for an API. And based on that, we can actually derive more information, more requirements on access pattern. How often will it be queried? How big will the payload? How often will it change? And only when we have queries, only then we can start designing schema, because this is like completely opposite that we are used to work in SQL space. Sorry about that. On the mechanism side, so when we start, we think, okay, what should we do? We have an idea, we design the schema, we all have all the queries, now we have the source database, and now how do we get that to the target? And if you have an application with a SQL side, the first thing you need to do is introduce some form of detecting and copying the data changes. I mean, most of people probably did it before in a microservice environment where you want to propagate data changes. This is very common. But the second thing is that we need to do is to also move cold data, because Many people also with SQL servers don't realize that the access pattern to the data is not equally distributed. That means that if you look at the data, how often it is queried in the table, for example, if you have billion rows, only a small fraction of this information is queried or changed. So that's why we have to look inside the data and say, okay, what percentage of data is actually not touched, and it's called data, and we can actually offload it without doing anything. So this is the easiest part of continuous migration in this case. Okay, so now we have to find out what is the mechanism. How can we go and find changes in our system? And the very famous one, probably most of people heard about that, is change data capture. How many of you used it before or heard it? Oh, nice, that's good. I think it should be more hands because Werner Vogels in the keynote today actually mentioned how DynamoDB replicates the data exactly with the same mechanism. So they stream the data changes and then they replicate it and apply it somewhere else. So this is the mechanism we have on a database level side when we want to take a look in the database and say, okay, we want to look in the data inside the database. But then there's another approach that is, sorry, wrong slide. Then there's another approach, it's called dual writes. Who did this one before or heard about that? Oh, not so many, wow, that's interesting, cool. Dual writes is something we want to do on an application level. We don't want to look in the database, we don't want to write queries. We are developers, we're lazy, so we try to modify code, introduce some changes in a secure way, and then ship a copy of the data somewhere else. So let's start first with the change data capture. Assume we have a Postgres database and we have a set of requests that are incoming on inserts, updates, and deletes. And what's interesting about SQL databases, most of the relational database management systems, they have so-called transaction logs. And transaction logs is a document that stores information about every data change in the database. This information is super helpful if you want to do rollbacks. If you mess up something, the system reads the transaction logs and says, okay, I'll revert the change because I know what changed before. And the transaction logs are also used for replicating the data. For example, RDS uses it heavily, DynamoDB, Redis uses replication as well for that. So when working in AWS environment, what really helped us in the past is to take a look at the AWS database migration service. And DMS is more popular for SQL to SQL migration, actually. And it was initially designed in the mind that you can move from different SQL servers. You can move from Oracle to Aurora and to use more open source technologies. And the way it works is that you first define the endpoints. So you need to configure the source endpoint and the target, so you have the communication in a secure way. You need to create the replication instance. This will be an instance in the background, an EC2 instance, and you describe in a task what should be done. So this is a document that actually specifies what table should we read, which column should we take as an input, and where should we store it. The interesting bit is that DMS supports not only DynamoDB for NoSQL changes, but it supports like way more things that you can do. And you can combine them as well, so you can ship your data first to S3 maybe, or to Kafka or somewhere else, and then do something else with it. It doesn't have to be DMS, just to be clear, there are open source solutions that support this as well. So for example, if you think of Debezium, you can connect it with the Kafka, and then you can process the data and ship it somewhere else and do everything with it. And the same works as well with the Kinesis, so it's more generic approach where you have more flexibility to stream the data first and process the high volume of data through Kinesis. And by attaching the Lambda function, you can just do whatever you want. You can do validation, transformation within it. You can discard things, filter. It's just up to you how you import it. So how does the DMS task look like, the document? Just to give you an idea how it actually is inside when you define it. So DMS task is a JSON document, and it's an array of rules, and the rules can be different, can have different types. So there is a selection rule, transformation. We will not cover them today, but the DynamoDB specific rule is object mapping, and this is where we can say we want to pick specific data point in our SQL database, and we can map it to a record in the DynamoDB. So here's an example when we have a rule, an object mapping rule, and we have an object locate that says we want to have in customer data, we want to collect customer names, and to insert a composite key, a key that contains 2 bits of information for DynamoDB, we can combine. And they come from different rows, actually, and this gives you a flexibility to decide how will my key look like and what additional attributes do I have to put there. The interesting part is also that it doesn't have to be a table. You can do it on a view as well, which means you can pre-configure how your data should look like in the DynamoDB, and then you can just read one record at a time, and you have exactly your key value pairs and the rest as well. There are some limitations in that, so you can't do something like blob files or large files doesn't work, and on types. So if you have something like timestamp, you have to convert into string to a different format, and then to convert it back based on the information you need. And we are here not to discuss to say this is the best approach. So in case you came here and wanted to know just a single approach how to do it, unfortunately, as always in architecture, there are trade-offs, and this is something we discovered over the time, and there is no point to say this is the best, but it's valuable to see when should we apply this approach, when we have benefit for that, and what are the challenges if we apply that. So first is you don't need code changes for that, which is amazing, because in some cases, some customers had systems that you cannot change really fast, so it takes 8 weeks or maybe a couple of months to test every change. So if you want to have some changes on a code level side, like with dual writes, it wouldn't work because it's just way too slow to roll it out and to test and have iterations. If you're in a situation, that's fine. You can say, I don't want to touch the code, just give me the access, read access to the database, and we can ship the data continuously, it's not a problem. The other part is the changes are atomic, which means everything you read in the transaction logs is actually the right, correct information that you can replicate somewhere else. So you can focus your failure handling and anything that can go wrong with data validation and data consistency after that. You don't have to, you can rely actually on this mechanism. Because SQL database exists for a long time now, there are a lot of vendors and products that support CDC, and I don't have the names here because there are way too many, but you can find something that will suit you if you go this path. And the other one is it's actually suitable also for moving large and huge volumes of data if you have the requirement. But there is a but. There are challenges, absolutely. So if you go this way, you have to create a lot of infrastructure, and this means you have to make it more secure, you have to spend more money on that, it's complex, you have additional work to do besides your shipping the features. The other thing is you can't sample, or it's way, way harder to sample and segment data. So what we think about continuous migration, and this we will see it in an example in a demo, we don't want to move entire tables. We're not thinking in, okay, we move a database, or we move a table, or we move these 5 tables at once, because you don't know how many records there are, like thousands or billions of records. It's hard to do that. And we want to get in confidence over time. So we want to focus the migration on very specific set of data. For example, I want to move one customer, just one customer, and I want to migrate it continuously. I want to gain confidence that it works, and then I can expand it. And with CDC, there are options, it works, but it's, you have to spend definitely more time if you want this flexibility. The other thing is, you're operating on a database level, you might need somebody who understands SQL, who understands your DMS, database management system, and things go wrong. You might need to configure stuff for transaction logs, or you might need to look into internal logs of the database to see why things didn't copy properly, why couldn't we read that, and so on. And this one is specifically for DMS and also other approaches where you have to provide a document, like it's not an instruction, it's just a set of rules, and these rules will be applied. And because we are in declarative space, we are not in imperative space, we cannot just write code and then this code will be executed and you can do whatever you want. You have specific features in this product that you have to use, and you are bound by these limits. You cannot escape them, and there are ways how to make it more generic, as I mentioned with Kinesis, and then you attach a Lambda, and then you're free to do whatever you want. But if you are in this space, you're limited, actually, to do that. The other thing is dual writes. So dual writes is basically on an application level. We don't access any data on the SQL side. We only operate on application level. So for us, it actually doesn't make any difference whether it's SQL or NoSQL on this side. We just blend it out and say whatever data is there, we rely on, be it object relational mapping or any other function. It will get the data from the database, and everything else we will do our own. Okay, so let's take a look how it works. So we will have an example here. So let's say we have a service and it writes data to a database. The first thing we need to do, we have to add the dual write capability. So when we process orders, we first write it to the database, and then we have to add additional function that says, okay, please ship a copy of this data to a new service or a new piece of code, whatever it is, that can write it to a NoSQL database. Okay, that's fine. So now we're just writing the copy. And this is the mechanism, this is the first step, and we don't rush. We just select, for example, one customer or one region or product type, and then we run it for a little bit, a couple of days, maybe a week, and then we collect the information. And we start thinking about, okay, how many writes did I do? How many of them are different? And there are some other mechanisms how to gain confidence. So we can have a good feeling over time, okay, we're doing the right things, the data is correct, and we can expand it. Then, if we have a good understanding, we think, okay, I think I'm doing a good job. Then we change the read priority. So instead of reading from the SQL database, we make a switch in our code and say, now every read goes to our canary, let's say, as a NoSQL database. So in this case, we just read it from the new database, and then chances are we did something wrong. So you can read from the old database there as well. This is the crucial point where we have to get our confidence here helps us to make sure that we switch the source of truth. So in this case, before we change the write priority, everything, the source of truth is SQL database. So whenever we read something in NoSQL, we have to double check, is it there as well or not? And over time, again, we will run it and we collect the data and we'll find out that both records actually match and we are in a good spot, so we can continue. Sorry, well. Exactly. In the background, during this whole process, after the changing the read priority, you can start thinking about moving the data moving the cold data to the NoSQL database. Okay. And then, after a period of time again, we gain confidence we can write to a different system, we can read from a different system. Now we ship or we flip the switch from what is the priority, what is the source of truth for this specific use case. Again, we are always operating on, we are migrating one customer or we are migrating a subset of data, and this will help us to understand that the mechanism actually work, and then we can expand it. So we just write to NoSQL, and the old database is standby. It's not only for only this customer, or only this portion of data, only this segment, and everything else goes exactly as it was for everybody else. Here's an example we have worked with customer. I can share. I can't share the name, but I can share the details a little bit. So they had a huge landscape of corporate center SQL servers. So they had over 1,000 servers, each server designed for one tenant. So they had tenant-based isolation on the database level. And they had a huge load actually on the SQL server. So they had a front-end application polling data all the time. It's like the same data was polled, but they couldn't cache it properly, so they decided to go the better route and just redesign the application and move part of the data that they have on the SQL side to DynamoDB. And what they did is they instrumented the application in the ECS cluster and created a new application. For them, it was AppSync and Lambda and DynamoDB. So on AppSync, they could actually replicate portion of the structure that they had on the SQL side, but they can improve it because there we have also types, we have the schema, and we have the queries, so we have roughly the same understanding how it works and how it should be shaped. And once they gain confidence, again, they run some experiments, some tests, they collected metrics, they put tons of observability there, and then they moved one customer by customer, one at a time. And after they switched in the front-end application, they had a different API call where they said, okay, this type of data I want to get from my AppSync, and the other, everything else goes from the old system. So dual writes are also controversial. If you read a little bit on the internet, people are a little bit scared, but there are some advantages when it works. So first is we can easily, really easily, to segment data. So because we can use feature flags, we can have branching, we can have different functions, libraries, everything we can use inside the code, we have the options there. And it's less infrastructure, actually. So you don't have to build any new things. You don't have to configure any IAM policies, any networking. You don't have to spend tickets and costs and so on and so on. Everything happens inside the code. And if you can change your code frequently, this is the best thing you can find. Yeah. But the challenges are the inconsistency. This is the biggest challenge that we have, actually, because things can go wrong. So you can write to the old database, and then you ship a copy, and then suddenly the database make a rollback, for whatever reason, or the transaction fails, and we didn't catch it. So you have just the wrong data on the other side, and you have to somehow find out, or at least find mechanisms how to catch that, how to make sure that the data is actually consistent on the other side. The other challenge is complexity. So if you build more and more functionality around shipping a copy somewhere else, then you have your error handling, then you have some more tests that you have to write. So there's a lot of code you have to evolve. And this is, again, this is not something wrong per se, but it's just the options we have. So if we go this route, we have to spend more time on the code level. If we go the other road, the other way, we spend more time on infrastructure, actually. And this one is also crucial, is because you will have a lot of data copying inside the application. You have to take a look at the resource you have assigned to your system. Because if it's running somewhere in a container and you spec like how much memory you can use, how much CPU you can use, it will increase, of course, because you have more activity on the application level. Testing. How do we make sure that things we're actually doing are not broken? So I call it the spectrum of uncertainty, and this is how I feel when I develop things. So I'm usually here, somewhere on the left side, where I'm not clearly sure that that's the right approach. I try to experiment, and I need some data, some tests, some validation that I did actually a good job. So it will be similar for when I run the demo. I will be on this side as well. And then we have the other part where other people are as well, where we have, okay, we think that's a good approach. I think we can ship it, and we're ready to go to the production. And there are ways how to get there. And this is just a subset of things you can do to get there. So first thing, you can start very easily just to compare a number of rows, very, very easily. You collect the data and then say, how many things did we write for this customer in this database, and how many rows do we have there? Do they match? No, we have a problem. Let's think about that, and let's find out. Then you can increase things and start looking into what are the values we are missing? Because the most problem we have there is we cannot compare row by row, and we cannot like compare everything. It's way too expensive there. So we start probing. We start experiment and finding things that might not work. It can be attribute types. It can be aggregations like min-max value. So for example, if you have sales data, you can just sum it up or pick an average, and if they match, then you are good to go. So it gives you a good confidence that things are actually correct, but not the confidence that you can ship, but you need to add more and more layer by layer so it works. And one of the things also that worked really well is randomized sampling, and this is where you start probing and just put some random samples from the source and the destination, and you pick, for example, 1% of the data at random from the source, and you get the IDs of the records. You roughly can estimate what it is, and then you compare the same stuff what is on the target side. So this means you spend less time, and it's less cost as well to compare everything. But if you do it more often, you get more and more confidence. The goal is not to compare everything, but just to find out whether it's not working. And then the question is, when do we test? Like, what are the hooks what are the steps we can do on the architecture side? So if you have a service and it talks to, for example, DynamoDB, the first thing you can add is a validation step. It can be a separate Lambda function. It can be something that just checks the types, the values, the structure, and you make sure that your inputs are correct. The issue is that we don't have the schema anymore on the NoSQL side. That means that if we need this strict validation, we have to implement ourselves. And on the right side, we can do monitoring. And this is a really important approach to add more observability and to run reports and to get more data and more confidence that things we're actually shipping are correct, that they're matching, that there are no errors, and we can generate reports based on, for example, sampling or other aggregations as well. All right, now it's time for a demo. Give me a sec. So in our demo, we will migrate one entity today based on 2 tables. I have to switch it first. Give me a sec. Beautiful. All right, so we have 2 objects, 2 tables in our database, and we map them to 2 objects. In our case, it's a device and an event. And each device has an ID number, some type, some status. It doesn't matter actually what kind of data is there for now. And we have a set of events that can happen, and our devices emit these events, and they send it back to our application and said, something changed here, you need to store this data all the time, constantly. And these are 2 tables, so this means we want to ship the events in our DynamoDB. And for that, we have constructed a new event that takes an event ID, a device ID, so it's a combination of data from both tables or from both objects. All right, so what we do now, we have 2 simulators. So one will be writing all the time, and the other one will be reading all the time. And how we implemented that is that we put some feature flags, and we will run deployments to AWS with CDK, where we switch the feature flags and we change the read and write priority for specifically this read operation. Okay. Okay, so the writer is sending events all the time, and this is good. Oh no, this is the wrong one. Good. Okay, it's going on. Now let's take a look at the X-ray. So it will take a little bit of time. So the way we have, I can show probably the feature flags first. We have two stacks. I've written it in CDK with Python, and this is a simple database stack with a REST API that we have here and a Python function that handles all the data processing. And we have a feature flags stack where we have defined this schema. Let me walk you through quickly. So we have 3 flags. The first one is, what is the customer? What is the tenant ID or the specific tenant in this case we want to migrate? And in this case, if it matches to any company, then we will apply dual rights and we will ship a copy of the data somewhere else. Then there is another flag where we just can turn off the writing itself. So we can first say, okay, now we want to switch the flag and write data. And the benefit here, you can switch it back and forth and just collect a little bit more information and data, how it works, how your mechanisms are configured, if everything is correctly, and if your observability tools show green sign. And then we can flip the switch again for the reading operation where we say, from now on, for this customer specifically, we don't use the old database, we switch it to the new database. And this happens without changing the code, so I just provisioned everything. The only thing I change are the flags. Okay, so these guys are running. Yeah, looks good. And here we should have a X-ray map. Okay, wonderful. So you can see here, I'm not a good magician. Here in Vegas, you have many magicians. I cannot hide, or I didn't create the illusion to have a SQL server in the back end. Because for dual writes, it actually doesn't matter if you write to SQL or not, because you operate on an application level, whether you have things in a SQL database or somewhere else, it's irrelevant. In this case, so we write to the Lambda function, and it's just the in-memory storage that we have. And from there, we copy the data to DynamoDB. So there is no DynamoDB yet. We're not migrating. Everything is great. Now, the tricky part, live deployment on stage. OK, now we switch the flag to true. And we say CDK deploy, feature stack. It will take roughly 40 seconds, I think, to deploy everything. Oh, that was fun. So in the DynamoDB, we don't have anything. Here's the table. Make it a little bit bigger. Nothing there, still publishes. It was faster when I was in a hotel. Maybe I can show something else. Give me a sec. Here's. So what I also did, I said, I want to see all the read and write. So I changed my code in a way that I emit metrics for every operation I run to the old database and every operation I run to the new database. And this will give me an indication, OK, am I doing good or are the numbers different? And this will give me a hint, OK, I need to change something. I need to go into detail why things are failing. So we have, let's say, for the last 5 minutes, we have 75 reads and 82 writes, which is good. Oh, deployment is done. Yeah, of course, I have the new version of CDK, sure. Let's take a look here. We have something. OK, now you ship a copy of a very specific customer to a new database, and we can take a look. And we see there are a lot of events, but just for any company, nothing else. All right, and our metrics should be updated. Here we go, successful DB writes. The issue here is that we have the writes from the previous run. So here are successful 17 writes to the old database and 24 and 17 to the other. So over time, we get some metrics. Well, nothing failed, luckily. that we can do. Oh, now they're equal, so that's good. Perfect. So now everything that goes into the old database is copied to the right side, and I can also show the code how it's done in a second. Now we flip the second switch where we say for this customer we want now to read only data from the old database. And if something fails, if we didn't find it in the old SQL database, we make a fallback. In the new database, we make a fallback and read it from the original. Okay, so here's everything good. Yeah, this one will not change significantly, so we might also close it. Yeah, so we're looking for this number here to change at some point. Maybe I can show the code how I have implemented that. So we have one main function. This is the Lambda function by heavily using AWS, our open source project, AWS Lambda Power Tools for Python, where we instruct here our Lambda handler to handle all the API calls that I will have. So it's configured in a way that whenever a specific API is hit, it will propagate the right objects to my annotations here. So I have a get method for devices. I have a put method, put and post for specific device ID on the events as well. So whenever I write something here, I create an event first. I use my store, and this is an abstraction that helps me to test my store operation, so I can put some different stores, so I can store in SQL or in DynamoDB, and in the code, it looks the same. I just instantiate different store in this case. And then I add a metric because this guy was good, and otherwise it will throw error and something else happened. But here I can collect metric all the time and say, okay, I want to add a metric to my successful writes, and then I try dual write to copy the data somewhere else. And here as well, I annotate which device ID did I try to copy somewhere else, so it gets me more visibility on the observability side. And I fetch first the more device information I need, so I can combine the data. And here I use the feature flags where I can say, okay, first I want to evaluate the flags for, am I allowed to write things or not? And if it's not the case, then this whole block will not be executed. And then the second part is also, is it the right tenant to migrate or not? So it helps also to segment things, to scope it a little bit more, a little bit less to migrate less data. And in try, I just use a different store, as you can see, the DynamoDB store, and I put an event in a new object, and then after that, I put a successful metric write. So at the end, I should have some nice graphs here. All right, so we can see the read match and the write match, which helps me to move forward and expand this thing and say, okay, I want this tenant is good, let's try a different one. And then you will find out, okay, these things are not properly working, and we need to fix something. All right, this guy is running. So just to summarize things, always starts with customer. Whenever you want to migrate the data to NoSQL, it's definitely tempting to start with the entity relationship diagram and draw everything and just come up with some objects and classes and everything. But try to go first to the customer side and understand what is the data structure they're looking for, be it an application that is used, a front end, a mobile application, or be it an API or an external service. Take a look at whether CDC or dual writes fit your case, because there are some challenges, advantages. They're not equally good or bad. They're just fit for different purposes in this case. Feature flags are like the most interesting and the most robust concept I've seen to segment things, to take just portion of data and not to say we think about moving thousands of databases at once, and we make so much effort to do that. I mean, it's viable for different customers, different use cases, but when you want to scope it down and you want to do it continuously, this is a skill you need to kind of like train yourself and just find out how can we scope it, how can we make it much, much smaller. Gain confidence with validation. There are things that will fail. It's inevitable. You write things that will fail. You will find out that data types are not matching. There are different order of things that it's inevitable. So trying to add more layers of testing, validation, and monitoring that will that will help you to gain confidence to, at some point, expand it in the future. Lastly, this is the common situation we see also customers. They start missing SQL features. This is like, okay, schema is actually a nice thing to have because it enforces everything. I don't have to write my function. I don't have to validate every type and everything. I just write it once and then it works. So there will be features you will definitely miss in SQL, and be mindful of that. It will teach you what you actually had and didn't pay attention to, and you might replicate them if necessary. And the last thing is absolutely vital, and this is also aligned to the core messaging that the Werner Vogels today said on the reInvent. It's evolve or die, because we have so many old systems, and it's absolutely challenging to, or it's also tempting just to start writing new systems. Like, okay, I'll write a new system. I will do serverless and event-driven everything, but it's much, much harder to evolve things. And the thing you write today as a greenfield application, you will have eventually to rewrite it in 2 years when we have new services or new libraries or something else. So I think from my perspective, it's super vital to take a step back and think about how can we train ourselves to evolve systems that we have right now and be more brave to, let's say, not fear any legacy system, not run away from them and say, oh no, there's a legacy project, I don't want to touch it. Try to find ways to improve it. There are solutions how to do that. There are ways. Try to be curious and find new ways how we can make business successful, but by turning old systems in new system and improve over time gradually. All right, we have time for Q&A. If you have questions, we have Mike there.